Okay, I'm in your packet on page 28. So if you can turn to page 28, and the questions are in this column, and then the answers are going to be in this column. So when you do these questions, I want you to just fold over the paper like this so you don't see the answers, and then you can check your work by flipping to the answers this way. I'm going to be going over this one, and I want you all I know you don't have a lot of space here, but I want you to write in the answers, and then if it asks you to graph, then just like a small little graph example like this so I can see the shape of the graph works. Okay, so I'm going to do this computer usage example. It says from 1991 through 1995, the number of computers, C, per 100 people worldwide can be modeled by C is equal to 25.2 times the quantity 1.15 to the T, where T is the number of years since 1990. Identify the initial amount, the growth factor, and the annual percent increase. So if I have my equation here, I know that my initial amount is the number outside of parentheses here. If there was no number here, then it would be an invisible 1. So this is the initial amount. So that means there are 25.2 computers per 100 people in 1991, because that's our starting year. And then my growth factor is 1.15. The annual percent increase is different. So the percent increase, or the rate, is equal to 15%. So our starting point is 1. We go from 1 to 1.15. So that increase there was 0.15, which turns into 15% when we move the decimal place over. So those are the answers for 22. 23 says graph the function. So I could either create an XY table, plug in values to plug in for T and solve for C, or I can just use Desmos. You guys will be able to use Desmos on the test. So I'm going to go to desmos.com. So desmos.com. I'm going to launch the calculator, and I'm going to input an expression, or I can just write here y is equal to 25.2 times 1.15. Shift 6 gives me that caret. Oops. Let's see what I do here. Shift 6, and I'm gonna get x, and x is my t. And here's my graph here. I'm gonna zoom out a little bit so I can get the general trend. And notice that my graph intersects the y-axis at 25.2. That makes sense because my initial value is 25.2. Your starting value, or the initial value here, will always be the y-intercept. So I'm going to do a quick sketch of that on my paper. So the main point that I want you to put on your paper is the y-intercept. So that's at 0,25.2. Estimate the number of computers per 1,000 people worldwide in 2000. So, and we're going to actually, this is a typo here, so it should say per 100 people. So you can actually cross out that extra 0 there. Estimate the number of computers per 100 people worldwide in 2000. Now, if I started in 1990 and I want 2000, that means I'm talking about from 0 to 9 years have gone by. So I want to find out when T is equal to 9. From 1991 to 2000, 9 years have gone by. So I'm going to go back to my graph. Now if I wanted, I could just plug in 9 here for T and solve for C. That would give me my answer. So if you have a calculator, you could do 1.15 to the 9, calculate that, and then multiply by 25.2. But I'm going to use Desmos. You can use either way, either method. So using Desmos here, I'm going to find out now. I put x instead of t, it doesn't matter. So when x is 9, I'm going to find my intersection point here. I'm going to keep going up, and I intersect when x is 9. So in 2000, when 9 years have gone by, I have 88.65 computers per 100 people. So 88.65, I'll make that down. So estimate the number of computers. Number of computers in 2000 is equal to 88. What was that number? 88.65 computers per 100 people. You could round that to 89 computers if you want.